For today's lesson, you will need in-class 29. This is the first day of Standard 7, where we are going to be focused on proofs that can use parallel lines in different ways. So our starting point today is to review information from Standard 6, where we learned about the angles formed when a transversal intersects two or more other lines, and then also what is true for those angle pairs when the lines are parallel, like they're indicated in this picture with these little flags. So the first fact that we're going to review is the corresponding angles postulate. This is now going to become a reason in our proof sometimes if we're dealing with a pair of corresponding angles like angle 8 and angle 1, for example. Those are corresponding angles because they are on the same side of this transversal, and then one of them is an interior angle, angle 8, while the other is an exterior angle, angle 1, and they're also in that same corresponding location. So in this little group of angles, angle 8 is the top right, angle 1 is in that same top right position over in its little group of angles. From Standard 6, if these lines are parallel, we learned that the corresponding angles postulate tells us that corresponding angles will be congruent to one another. Moving ahead to alternate interior angles, an example of those would be angle 8 and angle 3. Those are alternate interiors because they're on alternate sides of this transversal, one's above, one's below, and they are in the interior space between our parallel lines. Angle 5 and angle 2 would be a second set of alternate interior angles. Our theorem tells us, again, that if lines are parallel, that's always a requirement, these alternate interior angles will also be congruent. Our third type of angle from Standard 6 was alternate exterior angles. Those would be like angle 7 and angle 4. Like alternate interiors, they need to be on alternate sides of this transversal, so one above and one below, but then they won't be in the interior space between our parallel lines, they'll be in the exterior space. Angle 6 and angle 1 would also be a set of alternate exterior angles. That theorem repeats the requirement that lines need to be parallel first, but if that happens, then alternate exterior angles are the third type of angle that are congruent to one another. Then we get to our fourth and final kind of angle called consecutive interior angles. Those are not alternate. So if we start with an interior angle like angle 8, we need to stay on the same side of the transversal, but also stay in between those parallel lines. So an example of consecutive interiors would be angle 8 and angle 2. We could have also selected angle 5 and angle 3. Those are the ones that behave differently than all of the others. So when lines are parallel, consecutive interior angles are not congruent. Instead, they are supplementary, which means they add up to be 180 degrees, unlike the rest. So what we're going to do is we're going to recycle these 4 pieces of information that we already know from Standard 6, but we're going to use them in a different way now for Standard 7 because these are going to become reasons in proofs. There's one more important piece of information that we need to know, one more important vocabulary idea. We've reviewed this or we've used it one other time already, but it was in some notes where your teachers were proving to you why these theorems and postulates worked. And that property that popped up in those proofs was called the transitive property. So now we're going to officially talk about what that transitive property tells us and a couple of examples of how it can be used. And then we'll be off to start doing some proofs using the information. Transitive property can be used in angle situations or segment situations, but most often we'll see it used in terms of angles. But if two angles or segments are congruent to a third, then that tells us that they are also going to be congruent to each other. In English, that sounds a little bit weird. It's not super clear unless you really think through those words very, very slowly. So that's why we have a couple of examples here for us to take a look at. So let's read these examples as we read the words. So if two angles or segments are congruent to a third, so our two angles are going to be angle 1 and angle 3. They are both congruent to angle 5, the one that's underlined. Or over here, our two segments that are congruent would be these two, segment AB and segment CD. They're congruent to a third, segment WZ, that matches. So that's what this hypothesis looks like. That's what that beginning statement requires us to know. We have to have two angles that are both congruent to a third, or two segments that are both congruent to a third. And so then what the property tells us is that those angles or those segments, so angle 1 and angle 3, or segment AB and segment CD, are also congruent. So our conclusion is going to have a congruent sign in it to each other. So these angles that we highlighted are congruent to each other. These segments that we highlighted are congruent to each other. Now let's think about whether or not that makes logical sense. If angle 1 is the same size as angle 5, but then angle 5 is the same size as angle 3, these angles are identical. Imagine that they're both like 100 degrees. Well, that means angle 1 would have to be 100 and angle 3 would have to be 100, so that means angle 1 and angle 3 match. The same thing would be true about segments. Imagine that segment WZ has a length of 10. Well, that means AB has a length of 10 and segment CD has a length of 10, so they have to be the same size as each other. So anytime we're noticing this kind of repeated angle or this repeated segment, that repeated segment or repeated angle is going to disappear, and we're going to create a third congruent statement out of the leftovers. Angle 1 and angle 3 in the first case, or segment AB and segment CD in the second case. So we're going to be on a lookout for the postulates or theorems that we reviewed at the top, as well as the transitive property. And then they're saying we're also going to have some other previous knowledge, so we'll have to see what that is, that's going to help us to complete our proofs. These two proofs have exactly the same diagram, but they have different given information, and they have different prove statements, which means what we know is different and our goal is different. We're just using the same diagram for both, kind of like we did with our congruent triangles. All right, let's go ahead and jump in and see if we can talk about some proof strategy. I'm going to start, like I do with all of my proofs, by thinking through the given information. And we're not writing flowchart proofs for parallel lines because they wouldn't fit very well in our format from our congruent triangles in Standard 5. But I can still read the information and I can still try to think about whether that information would belong in a bubble or in a box. So as I read through, line M is parallel to line N. We know that every given is going to end up written into our proof. So I'm just going to copy it. It looks a little bit weird sometimes, so if you make those parallel symbols a little bit taller than your L's, that helps. Or some people use like a cursive L to make it pop up a little bit better. If I go over to my picture, I don't really see any evidence on the picture that line M is parallel to line N. So I'm going to go ahead and add those little flags that we know should be there when lines are parallel. That information is true because it was given to me. And I feel like if we were writing a flowchart proof, that would be bubble information. Because typically, we take our information and we turn it into congruent sides or angles. This does not have any congruent symbols in it yet. And in fact, congruent symbols wouldn't make any sense because lines go on for forever. So they can't have a particular measure and be congruent to something else. So I'm going to try to think about what could be congruent thanks to those parallel lines. But in order to make a good choice, I feel like I should probably also pay attention to my other given. So although this seems a little bit weird, I'm going to fill in my other given, angle 2 and angle 1, down here in statement and reason number 3. And then I'm going to kind of think about those angles in my picture as I'm considering how these parallel lines might be helpful. So, another piece of information that's going to help us is to pay attention to where we're trying to go. If we're trying to get to the point where angle 3 is congruent to angle 1, but angle 1 has already been talked about in a given piece of information, usually it's a good idea to try to think ahead to where the transitive property might help me out and to try to focus on the other angles that don't seem to be repeated yet. So I'm going to investigate angle 2 and angle 3 in my picture. They're living right here, connected by transversal K, which is really great news, because if line M is parallel to line N, and angle 2 and angle 3 are connected by a transversal for those parallels, I should be able to say something about them using one of my reasons we reviewed up there at the top. So let's try to give angle 2 and angle 3 a name. They would be alternate because they're separated by that transversal, but they would also be interior because they're trapped in between those parallel lines. So if I think about them as being alternate interior angles, that means I'm going to be allowed to use the alternate interior angles theorem from up top to say that angle 2 is congruent to angle 3. That is only true because of those parallel lines. So there might have been other things we could say were true thanks to those parallel lines, but the key is to pick something that's not only true but is also helpful. Remember that goal, because we want to eventually make our way closer to this particular goal, this proof statement, angle 3 congruent to angle 1, not some other random set of angles that might happen if we're not quite as careful. All right, so I've written my parallel lines down. I've used them to talk about some angles that seem related to the other given, which is in row 3, as well as to the proof statement. And then I noticed something really important sitting right here in statement 2 and statement 3. I've got a matching angle, which is exactly what happened up here when we talked about the transitive property. So if we know angle 2 is congruent to angle 3, but angle 2 is also congruent to angle 1, I think we're ready in statement number 4 to make the claim, to write down the statement that angle 3 is congruent to angle 1, thanks to our new transitive property. Now, that is all that's required to finish out this proof, but I will often write a little parentheses after the transitive property to explain which two statements I combine together. That just helps me to make sure I actually had enough information to use the transitive property, because sometimes your brain will try to play tricks on you and get you to use it before you're ready for it. But when I took statement 2 and statement 3, there was a repeated angle there, so that allowed me to make a transitive property statement with the other angles that were involved. That's optional. You don't have to have that, but you'll see me write that down each time I have transitive property because it helps me to make sure I'm truly ready to use the transitive property correctly.